Hello everyone, this is the part 3 of the mock test discussion. So let's begin. Here it says, this is question number 21. Let S be the set of 6 digit numbers A1, A2, A3, A4, A5, A6. All digits are distinct, where this criteria is satisfied. Then number of elements in set S is equal to what? So the number is of the form A1, A2, A3, A4, A5, A6, where A4 is the least of them. So there are altogether 10 digits with us 0, 1, 2, 3, and so on up to 9. These are 10 digits. So, in how many ways we can fill up? We can select 6 numbers out of this 10. So I have selected 6 numbers from these 10 numbers here. Then put the list of these 6 numbers in the fourth position, in the A4 position. So the total number of ways to do it is 1. And then we have to divide the rest of the numbers, that are in total 5 numbers, in 2 groups, group of 3 and group of 2. So we can select any 2 of those 5 numbers and then arrange them in their places. So the ways of arranging them in their respective places is 1. So the total number of elements in this set is this. You can calculate it easily. It will become 10C4, because NCR is NCN minus R into 5C2. This is equal to 10 into 9 into 8 into 7 divided by 24 times 5 into 4 into half. So this will become 3, then 3, then 10. So this becomes 2100. So that means 2100 is the correct answer for this question. I hope you understood this question. Now this is question number 22. Here it says area of the region bounded by the curves y equal to this and y equal to sec inverse greatest integer of minus sine square x is this. Then the value of n is asked. So first we need to simplify this curve. Here we know that sine x belongs to minus 1 to 1. So sine square x should belong to closed interval 0 to 1. That means if we put a negative sign here, minus sine square x will belong to the interval minus 1 to 0. Now we know that the domain of sec inverse x, it is minus infinity to minus 1 union minus 1 1 to infinity. And also we can notice that if we take the greatest integer in the minus sine square x, then greatest integer of minus sine square x will be either minus 1 or 0. That means greatest integer of minus sine square x can be fitted in the domain of sec inverse x if and only if minus sine square x greatest integer is minus 1. That is, if minus sine square x belongs to the interval minus 1 to open 0, then it will fit under the domain of sec inverse x. This is the only possibility. That means this curve y equal to sec inverse greatest integer minus sine square x will be nothing but sec inverse minus 1. and we know sec inverse minus 1 is pi. So this is the line y equal to pi. This is the second curve. And the first curve was given to us. It was y equal to 16 minus x square divided by 4. So now we have to calculate the area bounded by them. That means if we sketch a rough graph here, this is x-axis, this is y-axis, then the first curve we plot 16 minus x square divided by 4. That means it is a downward parabola like this with vertex at x equal to 0, and this point has coordinates 0, 4. Now this is the line y equal to pi like this. So the area bounded by them will be the area of this shaded region. So we have to calculate this area. If we want to calculate this area, we can see that this function is symmetric about y-axis. So the area will be simply 2 times this. This is the point, let's say x equal to alpha, then 2 times integral 0 to alpha upper curve minus lower curve integral dx. So upper curve is 16 minus x square divided by 4, then lower curve is y equal to pi times dx. Now we need to calculate this alpha. So alpha we can calculate easily. We have to simply equate these two. That means 16 minus x square divided by 4 is pi, or x square is 16 minus 4 pi, or x is alpha, so alpha is root under 16 minus 4 pi, or we can write this as 2 root under 4 minus pi, as alpha is positive here. So we can write this as integral 0 to 2 root under 4 minus pi. Then we can simplify this as 4 minus pi minus x square by 4 dx. So this integral becomes 2 outside, then 4 minus pi times 2 into root under 4 minus pi minus 1 by 4 into 1 by 3, then x cube with limits 0 to 2 root under 4 minus pi. So this becomes 2 outside, then this is nothing but 2 times 4 minus pi to the power 3 by 2 minus this is 1 by 12 times 8 into 4 minus pi to the power 3 by 2. So this becomes, this we can cancel, it becomes 2 by 3. So 2 into 2 into 2 by 3 into 4 minus pi whole to the power 3 by 2. That means it is simply equal to 8 by 3 4 minus pi whole to the power 3 by 2 in square units. That means it was given that it is equal to n by 3 4 minus pi whole to the power 3 by 2. That means the value of n is 8. I hope you understood this question. This is the next question. It says let ABC denote the sides opposite to the angles ABC respectively in a triangle ABC. So ABC triangle is like this. This is the angle A, this is the angle B, this is the angle C, and this is the side A, this is the side B, this is the side C. If B square plus C square equal to 20, 25 A square, then cot A by cot B plus cot C equals what? So first we have to simplify this cot to sine and cos. That means we can write this as cos A divided by sin A divided by cos B by sin B plus cos C by sin C. And this we can further simplify as cos A divided by sin A, and if we take the LCM of this, it becomes sin B sin C divided by sin C cos B plus sin B cos C. So sin of B plus C. Now we can further simplify this sin of B plus C as sin of A, because we know in a triangle A plus B plus C is pi. That means A equal to pi minus B plus C. If we take sine both sides, then sine of A is sine of pi minus B plus C, as sine of pi minus theta is sine theta. So this will be sine of B plus C. So here it becomes cos A into sine B sine C divided by sine square A. Now we know that in a triangle sine A by A equal to sine B by B equal to sine C by C equal to 1 by 2r. This is called the sine rule for a triangle. So we can substitute sine B, sine C and sine A here. That means it becomes cos A times BC divided by A square. All other constants will be cancelled. Now we can apply the formula of cos A. So cos A is B square plus C square minus A square divided by 2BC. That means BC times cos A, which is the numerator of this expression, it will be equal to B square plus C square minus A square divided by 2, and there is the A square in the denominator. Now we can substitute the value of B square plus C square. So it will be equal to 2025 A square minus A square divided by 2A square. As A is non-zero, so A square will be cancelled. So this becomes 2024 divided by 2, which finally becomes 1012. So 1012 is the correct answer for this question. I hope you understood this question. Here it is question number 24, the second last question of this paper. Let x, y, z be real numbers satisfying the system this. Then the value of this is asked. So first we need to check the domain of this expression. Domain of x, y and z. As x and y and z are fitted inside the logarithmic function, so x and y and z should all be greater than 0. This is the domain. That means their product should also be greater than 0. Now here, if we want to simplify this, we need to first remove this logarithm. That means we can write these equations as xyz minus 3 plus log x base 5 is equal to 2 to the power 5, so 32. Then xyz minus 3 plus log of y base 5 equal to 3 to the power 4, so 81. Then xyz minus 3 plus log of z base 5 is equal to 4 to the power 4, so 256. Now these are three equations we got. Now here our main motive will be to create a single variable xyz, because xyz is here, xyz is here, xyz is also here. So we can see that if we sum these three equations together, then this log x, then log y, log z will sum up to be log xyz. So there will be a term xyz created inside the log. So we have to sum these 3. That means we get 3xyz minus 9 plus, this will give log xyz with base 5. It is equal to, if we sum them, it becomes 9, then 6, then 3. That means 3xyz plus log xyz base 5 is equal to 378. This is the equation we got. Now see, this equation contains both polynomial and logarithmic function. So we cannot directly solve it. We have to use trial and error here. So trial and error. This is the only way to solve this question. That means if we take xyz equal to some variable t, then this equation is 3t plus log t with base 5 equal to 378. Now if we put t equal to 125 by trial and error, then we will get 3 into 125 plus log 125 with base 5, it is equal to 375 plus, this becomes 125 we can write as 5 cube. So log of 5 cube with respect to base 5 is equal to 3. That means 378. That means t equal to 125 is a root of this equation. Now how can we be sure that there are no other possible roots of this equation? For that, we need to consider a function, let's say 3t plus log t with respect to base 5. This is a function of t, and t is positive because here we discussed the domain of this system, which is equal to xyz greater than 0. So if we differentiate this function, f dash t will become 3 plus, this we can write as log t with respect to base e, or the natural log of t divided by log 5. So derivative of this will give us 1 over t log 5. Now as t is greater than 0, this derivative is always positive. That means f of t is strictly increasing function. So f of t is strictly increasing. That means if there is a line, let's say y equal to k, then this function must intersect this line y equal to k at most 1 times. So in this case, we can say that there are no other roots possible. That means xyz should be equal to 125. Now here we got that xyz minus 3 plus log x base 5 equal to 32. So from these 3 equations we get log x base 5 equal to 32 plus 3, so 35 minus xyz. This will be equal to minus 90. And similarly we can find log y base 5, which is equal to 84 minus xyz, so 125. So this becomes 1, 4 with a negative sign. And then similarly log z base 5 is equal to 256 plus 3, so 259 minus 125. This becomes 4, then 13. So if we take the modulus of this, then will be equal to 90, 41 and 134. That means the answer for this question will be the sum of them. So 90 plus 41 plus 134. So 90 plus this is equal to 5, then 175. So it is equal to 265. That means the correct answer for this question is 265. I hope you understood this question. This is the last question of this mock paper. It is a question from binomial theorem. Let a and b be two non-zero real numbers. So a and b are two non-zero real numbers. Okay. If the coefficient of x to the power 5 in the expansion of this is 27 times the coefficient of x to the power minus 5 in the expansion of this, then the value of 2b is asked. So first we need to calculate the general terms of these two expansions. So for the first expansion, the general term will be like this: tr plus 1 equal to 4cr into ax square whole to the power 4 minus r times 70 by 27 bx whole to the power r. So if we simplify it further, it becomes 4cr a to the power 4 minus r into 70 by 27 b whole to the power r times x to the power 8 minus r, 8 minus 2r, sorry, then minus r from here. So 8 minus 3r. And then we can calculate the general term of the second expansion. So then it will be tr plus 1 equal to 7cr times ax whole to the power 7 minus r times minus 1 whole to the power r times 1 by bx square whole to the power r. So if we further simplify this, this will become 7cr a to the power 7 minus r times 1 by b to the power r times minus 1 whole to the power r times x to the power 7 minus r minus 2r. So 7 minus 3r. Now we are to find the coefficient of x to the power 5 in the first expansion. That means we have to simply put this equal to 5. That means 8 minus 3r equal to 5. So r will be equal to 3 by 3, so 1. And if we want to calculate the coefficient of x to the power minus 5 in the second expansion, we have to simply put this 7 minus 3r equal to minus 5. That means r will be 12 by 3, so 4. Now for the first expansion, coefficient of x to the power 5, it will be equal to, if we put r equal to 1 throughout this whole expression, it will become 4c1 times a to the power 4 minus 1, so a cube, times 70 by 27b. And in the second expansion, coefficient of x to the power minus 5, it will be, if we put r equal to 4 throughout this expression, it becomes 7c4 times a to the power 7 minus 4, so a cube, times 1 by b to the power 4 times minus 1 whole to the power 4, so 1. So this. Now we are told that coefficient of x to the power 5 in the first expansion is 27 times the coefficient of x to the power minus 5 in the second expansion. That means we can write that 4c1 times a cube times 70 by 27b, this is 27 times 7c4 into a cube divided by 1 by b to the power 4. So as a and b are non-zero, a cube will get cancelled and 1b will get cancelled. So we can write b cube will be equal to 27 times 27 divided by 70 times 7c4, we can write 7 into 6 into 5 divided by 6, and then divided by 4c1, so 4. So if we simplify this, this becomes 7 and 10, then 2, then this becomes 27 into 27 divided by 8. Now we can write this as 9 into 3 into 9 into 3, so 9 cube divided by 2 cube. That means the value of b must be 9 by 2. So in this case, the value of 2b will be 9. That means the correct answer for this question will be 9. I hope you understood this question.